Now what we're going to do is we're going to find the derivative of the absolute value of a function. Well, what we're going to do here is we're going to actually look at the definition of absolute value, split it up into parts if necessary, and then find the derivative of those different parts. So we learned back probably in Algebra 1 and Algebra 2 that the absolute value of something, I'll just use x here, the absolute value of x, so let's just use a because we're using x over here. The absolute value of a is equal to itself. So the absolute value of a is equal to a if a is positive, greater than 0, or equal to 0. Now we're going to, 0 is a tricky one with derivatives, so we're going to actually maybe even split up more. And the absolute value of a, so if this was a negative number, the absolute value of a negative number is its opposite. So we want the opposite of a if a is negative or if a is less than 0. So we can use this definition of absolute value. So we're going to split it up according to the definition and differentiate the different parts. Please remember when you have a sharp point in your graph, which happens with absolute value, you don't have a derivative there. The derivative is undefined. So as we think of this one, if you can easily graph the function, by all means do that. It's helpful to see what's going on. So y equals the absolute value of x plus 2. We should know that this is a v shape. Absolute value is a v moved to the left 2. And so it's going to look like this. And so obviously the slope is different on the left than it is on the right, and right here at 2 the slope is undefined, so we're going to take that into account. So let's go ahead and write y, and we're going to write it as 3 parts, as I kind of mentioned up here that we can put it in 3. The absolute value of y is equal to itself, sorry, we don't need that, y is equal to x plus 2 if x plus 2 is positive, is greater than 0, which means x is greater than negative 2. So if we subtracted 2 from both sides. Y is equal to just 0 if x plus 2 equals 0, or when x equals negative 2. And the y is equal to the opposite of this, so negative x minus 2, if x plus 2 is less than 0. So remember, if what's inside here is negative, you have to do the opposite of it. If we were to solve this, this would just be x is less than negative 2. And so this is what y is equal to. And so the derivative of y, now that we split that into those different parts, is just going to be the derivative of each of these parts. So when x is less than or greater than negative 2, so to the right of negative 2, what's the derivative? Well, the derivative of this is 1. So the derivative is 1 if, and we're just going to go all the way to this one because this one is simpler, x is greater than negative 2. What happens when x is negative 2? Well, when x is negative 2, we have this sharp point in our graph, so it's undefined. And that's why we're splitting it into 3 parts rather than just 2 parts. If x equals negative 2, so it's undefined if x equals negative 2. And the slope to the left of negative 2, so less than negative 2, is negative 1. So the derivative of this, just looking at this function, is negative 1 if x is less than negative 2. And so the derivative is actually in 3 parts here. So moving on to this one, if f of x equals the absolute value of x squared minus 4, what's the derivative of f of x? Well, here we have an absolute value again, but actually these absolute value marks aren't even necessary because when we deal with functions, they need to be in the real numbers. So we have to think through this and realize that if we get a negative under our square root, it doesn't matter that there's an absolute value here. We can't work with that because it's not a real number. And we can think through this and think, well, we know that something under the square root, x squared minus 4, has to be greater than or equal to 0. And so x squared is greater than or equal to 4. And thinking through this, x has to be greater than 2, or x has to be less than negative 2. And so it can't be anything between 2 and negative 2. Now, it can be 0, so it has to be greater than or equal to. I didn't put the equal to there for those two. And so what we're going to do is we're going to look at this function and just take the derivative of it without the absolute value because it's not necessary, and we know, well, let's think of this. A lot of times we don't need the absolute value because that wasn't affecting the function at all, so we can think of this as f of x equals x squared minus 4 to the 1/2 power, and we take the derivative of that, and we get 1/2 x squared minus 4 to the negative 1/2 times the derivative of what's inside here, so 2x. And normally we would say as long as we're taking the derivative, we only take the derivative of the parts of the domain, but we do have to be careful with this one because when x, so 2 and negative 2 are part of our domain, but we can't take the derivative of those. So when we think of the derivative of x, we can put it in 3 parts, although 2 of them are going to look the same. If I rewrite this back in another form, so we have the 2 in the denominator, this is going to move to the denominator and be a square root. So x squared minus 4, it's a 4. And then the 2x will be in the numerator here. So actually I should have canceled these here. And so we don't really need those two. That's when x is less than negative 2, not equal to, because at equal to our graph is not going to be correct, or it's going to be undefined. The derivative will be undefined. And that's what I'll put here. The derivative's undefined from negative 2 to 2. And we know that the whole graph is undefined. The whole function is undefined from negative 2 to 2, except for at those values. But now the derivative is undefined there. And then back for the other side, for greater than 2, it's just going to be this greater than negative 2. Yeah, greater than 2, it's still going to be x over x squared minus 4. And that is the derivative. Oops, I didn't put this. So this is when x is greater than 2. So notice the function is defined for 2 and negative 2. I can put 2 in here and I can put negative 2 in here and I will get 0. The function is defined for those values, but the derivative is not defined for those values. Our last one, let y equals the absolute value of x squared minus 4. Another absolute value function. We're familiar with what's inside here, this x squared minus 4. We know that's a parabola. And that's a parabola that's opening up, that's moved down 4. 1, 2, 3, 4. So we have a few points here. So 1, 2, there's a point there. And this is the parabola. So when we graph that parabola, this can be helpful because we want the absolute value of this. But what does absolute value do? It makes everything that's negative become positive. Everything that was positive remains positive. So the absolute value of this blue part is actually going to be this red part. Anything that was below the x-axis is now going to be positive. So this 1, -3 will actually be at 1, +3. -1, +3. And this 0, -4 will be at 0, 4. And then same idea. So the function of the absolute value part actually looks like this. And so to take this, we can break this up into different parts. And we can say y prime is going to equal, and so really we have 3 things we want to look at here. This part over here and over here are part of the original parabola without the square root. So we can say the derivative of those is just going to be the derivative of x squared minus 4. So the derivative of those parts is just 2x. Well, where was that? That was when x was greater than 2, or when x was less than -2. So the derivative is just 2x. In these, they seem like 2 different sections, but they actually just have to do with x squared minus 4 without the absolute value. The derivative's undefined at the sharp points, which are when x equals 2 and x equals -2. So undefined at x equals 2 and -2. You could just put plus or minus 2. Well, what's the absolute value of this part? Well, this part in here looks like y equals -x squared plus 4. It's facing down, moved up 4. So the derivative of this part would be -2x. So -2x. And when is that? Well, that's from -2 is less than x is less than 2. Notice I didn't put the or equal to parts here because it's undefined at those values when x is 2 or -2. So again, this lesson, we found the derivative of an exponential function. We found the derivative of log base a. And then we talked through some strategies to help us find the derivative of the absolute value of different functions.